Hello everyone. Let's look at the new type pattern or the new type idiom in Rust. We will also look at operator overloading. We'll look at generics and trait bounds. So this code that we're going to write will cover all of those hopefully. So cargo, new, traits. I call my projects with 3 letters, then I know if that is 3 letters, I can delete them. So NV is just my shortcut for NeoVim. Let's write a trait. It's going to be called unit, and it is going to be bound with default and clone. We'll see why in due course. Just get rid of that hello world because it's annoying. Okay, and we will make a function called unit. Now we can have kilometers and kilograms. So those are the 2 units. So when I say unit, it was a unit of measurement. We'll just call it unit here for now. And just for our benefit, we'll assign it a static stir, or return a static stir. And now we've done that, sorry, these shortcuts are messing with me. Right, we will do a struct, which will be called kilogram. This will be one of the unit types. When I say unit, it's the unit of measurement, not the Rust unit. And meter. No, we will do. Next. We will need to implement units for kilogram, and then we can just basically repeat that, and we'll just do kg. So that's that one taken care of, and then we will implement unit. We need to implement unit because we're going to be restricting effectively we're going to be restricting the types of unit that we can use with our quantity struct, which we were going to build in a second. And we're going to do some stuff with generics in a second as well, which is when it starts getting fun. So, like a lot of things, kind of put things off if they're too complicated, or I wouldn't say just say too complicated, but almost why is that complaining? Oh, because it's complaining because we need derive and debug. And this, I know because I've done this and practiced it before, but we will implement debug default and clone and copy. Let's got rid of that warning message there, and we'll do it here as well. And that compile. It compiles, but with the warning. So just going to allow unused temporarily. There we go. That's good. Okay, so we've got a kilogram or a meter. So we want our struct quantity to be able to use meter or kilogram. So struct quantity, and this is going to be generic. So, or it's going to accept a generic. And that will be either a value, sorry, it will have a value, which will be like 10, 15, and then it'll have the unit, which will be kilograms or miles. So unit will be whatever U is. Okay, and we probably need to, let's we'll derive debug here because we're going to print it in due course. So just to summarize, what we've done so far is we've built a trait, which is unit, which is then going to be applied to kilogram and meter. So that then allow us to use the generic. So when we actually create a quantity in main, we can either have a weight or we can have a distance. And then the important bit here, which is where we get onto the operator overloading, is we also want, let's go back up to the top, and we want to use stud ops and then add and subtract. So we will implement our own version of add and subtract, which will be for either the kilogram or the meter unit type. So this is where it starts getting quite, I wouldn't say complicated, but so the way I understand it really is that with generics, they are something you really, really need to be proficient at if you are writing libraries or code that other people will use. If you're just writing quick and dirty code for yourself, you can probably avoid them a lot of the time. But if you want to be a proper programmer, I suspect you need to be very au fait with generics. So the first thing I'm going to do is import. I'll just put add here for now. Import add for. So we can implement add for quantity, which we know has got a U in it. But now this is where we put in unit. Sorry, U, which is bound by the unit trait. There we go. So then if we do, let's just do fn. So it throws up the option of fn add. It's not giving us an error so far, but it will because it needs this. When you do add or when you use stud ops, you need to do type. So see, because I've got Rust Analyzer here, it's doing, I do type and then it knows that it needs output, and then the output will actually be a quantity, which will match whatever the generic type happens to be. This RHS, I've read some places that right and left is gradually being superseded by start and end because some languages work the other way. So I'm just going to call this other. Okay, so then we want the fact. I think rather than self output, we put quantity U here as well. So we'll return a quantity of whatever the generic U type is. Then we do quantity here. It's off from the autocomplete just there, wasn't it? So then we do the value, which will be self.value plus other.value. And this is particular to the to add and subtract from standard ops. Now, unit, this is where the default comes in handy. So we would do U, whatever the unit type is, whether it's kilograms or is the default that comes with the trait, which comes with whatever we've used as the U, which is the unit type. Okay, so default. There we go. We've got no errors so far, so it's looking good. And then if we just wanted to, we could do subtract as well here, which would be the same, but we'd just change plus there, and we would just change that to sub. So let's do it while we're at it. Not really learning very much doing this, but just for completeness. And then sub. Got a horrible error here where everything goes funny color. And then if we just replace that to minus, And duplicate function name as well. So okay, that compiles. Now we actually want to make use of these, so we will say let d1 equals, so we'll use distance to start with, which will be the meter. So here if we say let d1 equal quantity, so whatever the quantity is, and then we need to specify the unit. So we will do quantity meter. So notice how we're actually using the angle brackets here to specify the type, which is effectively we're wrapping this. If you also look up wrapping, we're creating our own types, but really we're wrapping whatever you create. You're always working with primitives under the bonnet. So eventually, so then the value can be 10.1, and the unit will be beta. I'll just copy this, paste it, and I'll just do Control A on that, and do that. And now this is where we come to use our add. So if we do let result equal d1 plus d2, so we're adding two structs together. We can only do that because we've implemented add for our struct. And it knows that the result is a meter. Did you see how the auto the inlay hints work there? So if we compile this, compile fine. If we print it, let's just print result dot value, result dot units. We can get rid of. We actually don't need the debug there, really, do we? We could have done without those. Value, and then why is it complaining? Oh, it does need debug. My bad. Run it. Yeah, you see it's done the floating point error, so we need to do on the value. We just need to do dot 2, format it to 2 decimal places, and there we go, 20.3. So it's added the value that is inside our quantity struct. So we've got a struct called quantity, which contains a value and a unit. So all of this is fine, but what's the actual point of even making it generic unless you're going to use it? So let's do it again here. Let W1 equal quantity and kilogram, curly braces, and then we would do the value, which will be 2.1, and the units, which will be kilogram. Just paste it in with the Control A there, just to bump it up by 1. And then we will do net results to equal W1 plus W2. You know what's going to happen, don't you? This, can we copy that? Can. I'll just change that to 2. Okay, good. So there we go, 5.3, and the unit was kilogram. So with our quantity struct, we can then pass in the type. So here we're passing in meter, kilogram. And if we remember right at the very top, we used default here. If we didn't use default, would this still work? No, it wouldn't, because let's see what error we get. You see, even there it's telling us. So the way around it, we could have done unit plus default in our import. So if we look up here, could have done default, and we could have done it there as well. So there's two different ways of doing it. You can either do it in the trait at the top, or you can do it when you actually use the trait. So, and that works fine. So two ways of doing it, and the compiler actually recommended us to do it here, you see. So there's always more than one way to do something, isn't there? So going back to the theory, what we've done here is we've used generics, we've used trait bounds. So we've said use the unit trait where whatever you're using it with implements clone and then subsequently default. We've created a quantity struct which can take either a meter or a kilogram, because that's the unit. U is the unit, belongs with the unit type, which has been applied to our kilogram and our meter. Watching this, it will make sense to you, but until you actually try and type this in, quite often when you don't copy and paste is one of the best tips I was ever given, because if you copy and paste, A, it's not going up into your brain, and B, if you type it, quite often you'll make a typo and then you'll see the compiler errors, and you're teaching your brain what compiler errors you are likely to encounter, and then you begin to understand what's going on. A bit like if you're fixing your car and steam starts coming out of the bonnet, then you know you got a problem with the radiator. But if you'd never fixed a car before, you probably wouldn't know what the steam was. And anyway, that's I'm going off on a tangent. But debug, default, clone, copy. What if we hadn't used default here? Would we get an error? Yeah, because our struct needs to implement default as well. So by including it there, you then get the ability to use default when you actually use the unit here. So in fact, that's probably how it should be. If I do format in a minute, let's just see if it, okay. Yeah, you see the space there. Apologies for my typing earlier, because that could have looked misleading, but thank you for watching. I know this has been a bit, I wouldn't say exciting, but it's just something to kind of expose yourself to with a view to being more an advanced Rust programmer, because you sooner or later you want to start writing code that other people can use if you're writing a crate or whatever, and then you will be wanting to use generics more. And it's just a good, in fact, earlier examples when I started learning Rust just had whatever's here after the struct name, I only ever saw same here. So to begin with, you'll probably only ever come across examples where the import has got the same there as it has here. So it's good just to start gradually getting familiar with using what was it? Default. Done that the wrong way around, but it's fine. Yeah, it's good just to start being familiar with using impulse where you've got trait bounds. Any questions, drop me a comment. I'm still learning this, by the way, so if anyone's got any good tips or can explain any of this better. By the way, just for completeness, you don't actually need that there for that trait. It really is just like a trait bound. So you're just saying if something, it's almost like a label. You're saying if, what do you need? Okay, we need to keep the empty parentheses here. Go, and up here, we need, let me just get rid of that. I think that's causing the error. So yeah, for the trait, you can just use like a trait as, it's almost like a marker, and you're just saying, or using it as kind of a label, so to speak. So does that compile? Indeed it does. So you see with the trait, you can just have, effectively it's just a label and it's not returning anything and it's not doing anything. But because we've got this line here, we can then use it here, use it here. So we're saying that this unit trait, you're labeling the kilogram and the meter with whatever that trait is. Let's say down there, that U actually is whatever you want it to be. Well, given that you've declared a unit is a type U, so you're passing in either what you're passing into that unit there, actually whether is the meter or it's the kilogram. So turn off type hints, it probably cleans it up a little. There you go. If it's giving you inspiration to go and practice this, and that's the aim of this video, it's not kind of a university level tutorial or masters of computer science. It's more of just familiarizing yourself with using trait bounds and just being aware of the new type pattern, and just get familiar with attaching traits to strict what you can and can't do, or what is, it's basically ensuring that something is compatible, really. That's how I understand it. So thanks for watching. I'll be back soon.